one of the previous question. So convert the following context-free grammar into Chomsky normal form. As per the procedure, what we demonstrated, follow step by step. Step 1, remove all null productions, unit productions, and useless symbols. The given context-free grammar, sometimes it won't contain any of these, but that is the prerequisite step we have to follow. Therefore, given CFG, check out given CFG contains, see there are no null productions. Right hand side you don't have a null value, any of these two productions, that is E derives E plus T or T, then T derives A or E within parentheses. So in the given grammar, terminals are, what are the terminals here? Plus small a, open brace and closed brace. Then variables are all uppercase letters. Capital E, comma capital T. So here right hand side there is no null value. CFG contains, first you can mention, does not contains null productions. The first point in step 1. If null productions are there, you can remove. If not there, you can proceed to others. Then point 2, check unit productions. Given CFG, SCE derives T, right hand side single variable is there, but T does not contain a single variable in the right hand side. Given CFG contains one unit production. We will also do this one. This we already discussed. Unit production, that is E derives T. So remove this by using substitution rule. So you can use substitution rule here. For removing unit productions, we will use substitution rule. Therefore, E derives. Now, what is T? Substitute all the T productions. T derives A or E within parentheses. Terminal A or E within braces. So this is the resultant production of E derives T after removing unit production. Now check out the remaining productions as it is, you can consider. Now final CFG is given below. I written all the final productions. Now E derives E plus T. E derives E plus T, or these are the new productions of E, that is terminal A or E within parentheses. Now T productions remain same. There is no change in T. Terminal A or E within braces. Now you can see, check out useless symbols are there or not. To check usefulness, the 2 points are here. You can see every variable must and should derives a terminal or terminal string. Here E derives a terminal, direct terminal is there. Then T derives A, also derives. So both E and T are deriving terminal strings, terminal or terminal strings. So there are no useless symbols. No useless symbols. But you can't stop here. You can proceed to second aspect also. What is the second aspect? every variable must and should reachable from the starting variable. So for that, construct dependency graph. Every variable should reachable from start variable. Here S equal to E. That means the first production starting with E. So that is starting variable. So now this can be done by constructing dependency graph. This can be done by using dependency graph. Now you can construct dependency graph for starting productions. You can take the resultant E productions. So E derives E plus T or then terminal A or E within parentheses. For this, you can draw its dependency graph. First, you can take the starting variable E, then right hand side variables. Right hand side, other than E, the new variable is T. Now E is the starting variable. Check out there is a path from E to T or not. Yes, T is there in the right hand side. Therefore, there is a path. So T is reachable from E. Therefore, there are no useless symbols. No useless symbols means then automatically no useless productions also. Therefore, final CFG. Then coming to step 2, final CFG from step 1. Now you can write in the final grammar. So same only. E derives E plus T or A or E within parentheses. Then T derives A or E within parentheses. Now you can apply step 2 for this. That means after performing step 1, if all the productions are in the form of check whether all productions are of the form A derives BC or A derives terminal A. Two variables length or single terminal. Then the grammar is in Chomsky normal form. Check out. So here you can see E derives E plus T. So here E is the variable, plus is the terminal, T is the variable. So it does not contain two variables. Then E derives terminal A. Okay, this is in the required form, single terminal. Then E derives E within parentheses. Here terminal variable combinations are there, not in the required form. Then T derives A, terminal A, only in the required form. Then T derives E within parentheses, is not in the required form. Therefore, from the above CFG, only E derives A and T derives A are in the required form. That means are in CNF. So, but others not in CNF. For other productions, you can proceed to step 3 and step 4, which are applicable. Therefore, coming to step 3, for which productions you can apply step 3? First, consider non-CNF productions. Consider non-CNF productions other than the above two. That is E derives, therefore E derives E plus T or E within parentheses. Then T derives E within parentheses. Now let us consider one by one. First, E derives E plus T you can take. See, this is in the form of, here this is variable. Now this is terminal. Again this is variable. So by applying step 4, why? Because wherever the terminal is there in between variables, we can apply for step 4. By applying step 4, for place we have to introduce a new variable. Introduce a new variable for the terminal T. Say D suffix T, which is belongs to V. Therefore, E derives E. Now plus becomes D suffix T. Now T. So here, what is dt, that you can write down. D suffix T derives plus. Now you can see dt derives plus is in the required form, is in CNF. But E dtt is not in CNF. Then you can apply not in CNF. So here 3 variables are there. That is more than 2 variables. N greater than or equal to 3. So you can apply step 3 for this. By applying step 3, what you have to do? You can split the right hand side variables with the length 2. With the length 2 by introducing new productions and new variables. To split right hand side productions with length 2, introduce new variables and new productions. Therefore, E becomes, therefore E derives, here it has 3 variables, E dt. So you can take E as it is, that the remaining 2 variables we can substitute with new one. Let us say d1. Now d1 derives dtt. d1 derives dtt. Now see here 2 variables. Here 2 variables. So these 2 are in Chomsky normal form. So now dt we already introduced above. dt derives plus. Then d1, now here the new productions are defined. Now these are all the new E productions which are in Chomsky normal form. So E plus T is over. Then another one, E derives E within parentheses. Another non-CNF productions of E. Now let us consider E derives E within parentheses. Again here you can see it is in the form of step 4. This is terminal 1 variable, then terminal 2. By applying step 4, introduce new variables for the terminals. Here 2 terminals are there for the terminals, left brace and right brace, as D left braces, then D right braces respectively. For our understanding purpose, with the same terminal nomenclature, if you can introduce the variable name, then that is easy. So therefore, E becomes, therefore E derives. Now the left brace, you can substitute the variable D suffix left brace, then E remains same, then right brace, D right brace. Again see here three variables are there. So now apply step 4. So you have to split by introducing again new variable and new production. So introduce new variable and new productions. Before that, here you can see what is D left brace derives left brace. Then D right brace derives right brace. So these two again are in CNF. Now you can split the three variables. Therefore, E derives D left brace. Let us say start with new variable. Here we have D1. Now we can take D2. Now D2 derives E D right brace, where D2 derives E D suffix right braces. Now you can see D left braces D2 variables length 2. Here E D right braces. So the suffix value is not considered as the terminal. That is just for variable name. Therefore, these two are in CNF. Now you can see all E productions are reduced to CNF. Then coming to T productions, here T contains E within braces. T derives terminally, that is already in the required form. Now the third non-CNF production, T derives E within right braces. See, for left brace and right brace, we already introduced in the above step the variables. So you can substitute, use D left braces and D right braces in place of left braces and right braces. Therefore, T becomes T derives D left braces, then E D right braces. Again, you can see three variables are there. By applying step 3, whenever splitting variables, that can be done using step 3. Whenever terminals are replaced by variables, you can apply step 4. By applying step 3, so you can introduce a new variable T derives D left braces E. So this entire E D1, let us say some D3. Now D3 derives E D right braces suffix value. Now you can see here are two variables D suffix left parenthesis D3. Then D3 derives E D suffix right parenthesis. So are in CNF. Now D left parenthesis derives left parenthesis. Already in the above step, those are all introduced. Here again, no need to add. So now you can see all the productions. E derives E plus T is reduced to CNF. Then E derives E within braces is also reduced to CNF. Then T derives T E within braces also reduced to CNF. Now already in step 2, some of the productions are in CNF. Then in step 3 and 4, we obtained some productions which are in CNF. All you can write down now. Therefore, the final CFG G dash is in CNF is given below. Now write down all the productions. First, step 2 you can write down in order. You can write down. In step 2, E derives A, T derives A. But all you can combine with starting with the same variable name. So here E derives A, then T derives A. Now what are all E productions you can combine here? starting with same E variable. In step 3, whatever the productions which are in CNF starting with E, all you can write down. So all are rounded in rectangle box. So here you can see E derives ED1. That is one new production. ED1. Then what are other E productions? Then here E derives D suffix left parenthesis D2. D suffix left parenthesis D2. Okay, that's all about E productions. Then write down all T productions. T derives A followed by what are the new T productions which are in the required form? D suffix left braces D3. D suffix left braces D3. Now here some new productions are also there, starting with a new variable. So that is D1, D left braces, D2, then D3. All you can write down here. Now, what are D1 productions here? D1 derives, here you can see, D1 derives D suffix T plus D suffix T, T, D1 derives. Then D2 derives E D suffix right parenthesis. D2 derives E D suffix right parenthesis. Then what are other new variables? D1, D2 or D suffix left parenthesis. D suffix left parenthesis derives a terminal left parenthesis. Then D suffix right parenthesis derives a right parenthesis terminal. Now what are the other new variables in the right hand side? In D1, D suffix T is there. So that is also another new variable. What is its value? D suffix T derives what you have taken here, D suffix T equal to plus a terminal plus. If you want here also T, you can replace it by plus. Then the nomenclature should matches with terminal value. Here it is plus. Now wherever D suffix T, you can introduce it as the symbol plus. D suffix plus. Then check out any missing variables and productions are there. Now you can verify all variable productions are covered here. Now you can check finally all the productions are in the form of two variables length or a single terminal. Now you can verify E derives A single terminal, E D1 two variables, then D suffix left braces D2 two variables, T derives A terminal single terminal, then T derives D suffix left braces D3 two variables length, then D1 derives DTT two variables, D2 derives E D suffix right braces two variables, D suffix left braces derives left braces single terminal, then D suffix right braces derives right braces single terminal, then D suffix plus derives plus single terminal. Therefore all productions are in the form of with the two variables length or a single terminal. Therefore this is the grammar which is in Chomsky normal form. So like that each and every production we have to reduce to either two variables length or single terminal in the right hand side. Then only you can say the grammar is in Chomsky normal form. So like that for any given problem we have to follow this procedure with 4 steps combination. Now here one more problem is solved here. The second example, to convert the following CFG into CNF. S derives AAC, A derives AAB or null, then C derives AC or C. Anyway, the solution is included here. Now I will explain briefly. You will also practice this one. Now you can see the given CFG, step 1, eliminate all null productions, unit productions and useless symbols. If any of are there, you can eliminate. Otherwise, you can proceed to step 2. Sometimes the given contextual grammar does not contain unit productions, null productions and useless symbols. Then what you have to do? Directly you can proceed to step 2. Now here you can see in the given grammar, A derives null, epsilon is there. By seeing this directly, you can identify null productions are there. So first, eliminate null productions here. Now you can see, given CFG contains a null production, that is A derives epsilon. To remove null productions, the resultant grammar is, wherever A is there in the right hand side of all productions, you can substitute null one at a time with all possible combinations by taking the original production as it is. Then direct null value production, directly you have to remove. Now here you can see S derives AAC. This will becomes, first leftmost A is substituted by null. Then you will get AC as the result. Then middle A. Also if you can substitute null, again you will get AC only. But no duplicate productions are considered. You can take only one time. Then two combinations. If you can substitute two variables as null, that is both A's as null, then you will get C. Here 2 times A is substituted. Then A productions, A derives null is there. Directly you can remove. Then in other place also variable A is there in the right hand side of A. A derives AAB. Here A. You can substitute null by keeping original production as it is. Then you will get AB as the terminal string. Here A is substituted null. Then C does not contain a nullable variable or null variable in the right hand side. So there are no null productions in C. So this is the final grammar after eliminating null productions. Now from the resultant grammar you can verify next one, unit productions. Unit productions we can identify easily by seeing a single variable in the right hand side. Here you can see S productions, S derives C. Here single variable is there. Then other than this one, remaining does not contain single variable in the right hand side. Therefore S derives C is the unit production. Now you can remove S derives C, unit production. So the resultant grammar contains a unit production, that is S derives C. So remove S derives C by using substitution rule. That means the C productions you can substitute in place of single C. Now S becomes S derives AC or C. Why? Because we substituted C as AC or A. Now the final CFG after removing unit productions. Now you can see here only S derives C is substituted, remaining all same as above. Now this is the resultant grammar. Now you can check out usefulness. Any useless symbols are there or not. For that, to verify usefulness. To verify usefulness, here we have two aspects. The first aspect is all variables should derive a terminal or terminal string. Now in the given resultant grammar you can see yes derives a terminal directly, right hand side a single terminal is there or more than one terminal also. Then A derives AB, A also deriving a terminal string. Then C derives A, also deriving a terminal string. Therefore S derives A derives AB, C derives A. So all variables deriving terminal string, satisfying the first condition. Means there are no useless symbols as per first aspect. Then second aspect, for S productions, you can draw its dependency graph to check the reachability of the variables which are deriving from the starting variable or not. Now the S productions are S derives AAC or AC or terminal A variable C or terminal A by using dependency graph only for starting variable productions. Now left hand side S is there, that is starting variable. Right hand side we have A, then C. Take both A and C. Now right hand side in the S productions A is there. So S derives A. Then right hand side of S variable C is also there. That means there is path from S to A, then S to C. So both A and C are reachable from S. Therefore now second condition also satisfying. Means there are no useless symbols. Therefore there are no useless symbols means automatically there are no useless productions. That is the step 1. Now coming to step 2, consider the final CFG G dash obtained in step 1. This is the final CFG. Check out if it is in the form of CNF. That means every production in the right hand side with the 2 variables length or a single terminal. Then only the grammar is in CNF. Check out say S derives AAC, 3 variables are there, not satisfying condition. But S derives AC, 2 variables, it is satisfying. Then S derives terminal A variable C, not satisfying. Then S derives single terminal, satisfying the CNF condition. Only 2 S productions are satisfying, others not in CNF. Then A productions both not satisfying. Why? Because terminal variable terminal not in the CNF form. Then terminal A, terminal B not in the CNF form. Then C derives terminal A variable C not in CNF. Then C derives A single terminal is in CNF. Only in S 2 productions, in C 1 production are in the required form. Remaining are not in the required form. For those you can proceed to step 3. Now check whether all the productions are of the form A derives BC or A derives A. Only 2 productions are there. S derives AC or A, then C derives A or in CNF. Now remaining are not in CNF. For those you can apply step 3 and 4. Now coming to step 3, let us consider the non-CNF productions. So S derives AAC, S derives terminal A variable C. Then A derives these 2, C derives this one. So these are all not in CNF. So you can apply rule 3, step 3 or step 4, whichever applicable. First, let us take S derives AAC. Here you can see it is in the form of step 3. S derives A1, A2, A3. N greater than or equal to 3. 3 variables are there. By using step 3, what you have to do? Split S by introducing new variables and new productions. Then this will become S derives A D1. So the first variable as it is we have to consider the right hand side 2 variables. We used another new variable substituted. So D1. Now what is D1 here? D1 derives AC. Now we can see it contains 2 variables A D1. Then D1 derives AC. So in CNF, these new productions are in CNF. Then other S productions are which are not in CNF. S derives terminal A variable C. Now you can see terminal A variable C. So here right hand side terminal followed by variable. It is in the form of step 4. So by using step 4, introduce a new variable for terminal A. Let us say D suffix A. So here for our understanding purpose, whatever the terminal name, the new variable you can introduce by adding suffix as the same terminal. So here D suffix A is introduced for the terminal A. Now this you can substitute here. Now S derives D suffix A C. Now you can see 2 variables satisfying the CNF condition. Now what is the DA? That is a new variable. Write it to productions. So DA derives A. So therefore in CNF. Now these 2 productions are in CNF. Now all S productions are converted to CNF. Then coming to other productions, that is A productions. So A derives terminal A, variable A, terminal B. So which is not in CNF. Again you can see this is in the form of step 4. Why? Because terminals followed by variables combination. Now for terminal A, we already introduced DA in the previous step. Substitute same value. But terminal B, you can introduce a new variable. For terminal B, introduce a new variable, say D suffix B. Now both variables in place of terminals you can substitute. Now A becomes A derives DA, A, DB. Now you can see this is not in the required form. Why? Because 3 variables are there. Again you can apply step 3. But what is the DB that you can write here? A DB derives B, which is in CNF. But A is not in CNF. Now take the A new productions. A derives dA, A dB. Now by using step 3, we have to split. Why? Because more than two variables on the right hand side. Now A derives dA remains same. Now A dB is substituted by introducing new variable, let us say D2. Now what is D2 derives A dB. Now see this one, two variables length A, then D2 derives A dB, two variables length. So both are in CNF. Now all A productions are reduced to CNF. Then another one is there, terminal string AB. There two terminals are there. So A derives AB. So again by step 4. Now here you can see for terminal A we introduced a new variable in the above step. Then for B also we introduced. So both variables for these terminals already introduced. Again no need to introduce. Same variables you can substitute here. So here A derives dA dB. Now dA derives A already added in the previous step. dB derives B already included in the previous step. So don't take duplicate productions. So therefore this is directly with two variables length is in CNF. Then coming to C productions. C derives terminal A variable C. So again C by step 4. Why? Because right hand side we have a terminal. Now for A terminal A already a variable is introduced in the above. Same variable you can use. Now C derives dA C. dA derives A already included in the above. No need to add. Now you can see already and consisting of two variables length. Therefore, C derives DAC is in CNF. Now, the final CFG G dash, which is in CNF, is given below. Now, all productions which are represented in rectangle box, starting with step 2, all you can write down here in order. First, S productions, S derives AC or AD1 or D suffix ARC. Now you can see AC, two variables length, or single terminal A, or AD1, two variables length, or DAC, two variables length. So all S productions are in CNF. Then A derives DA-D2, so two variables. Then or DA-DB, two variables. Then C derives DAC, two variables. Then C derives single terminal. Then D1 derives AC, two variables. Then DA derives terminal A, single terminal. DB derives B, single terminal. D2 derives ADB, two variables. So whatever the new variables, new productions, all you can include in the above, whatever you reduced into context-free grammar. Therefore, this is the final grammar which is in Chomsky normal form.